meets at point A. So okay, mark at point A, and this is IA XD right here. IA XD from here till here. Now cut IA XQ, same procedure. So from here somewhere, let us say this is IA XQ length. Obviously XQ is lesser than XD, so we will have somewhere, let us say this point. Now next procedure was extend this point by joining this point O, let us say O. So first join this point and extend this. Now draw perpendicular from this point on this, and let us say this is B point, and join this. This will be our E phasor. So this is our E phasor, and this is same line, and this is our power angle or load angle delta. Fine. So both way we can draw phasor diagram for unity power factor case for both salient pole. So far we have drawn for salient pole only. Now come to the cylindrical. So for cylindrical I am drawing here. So this is our V phasor. This is our IA phasor in the same phase. Let us take this as O point. Now next step is draw IARA drop. So it obviously in the same phase as that of IA. So this is IARA drop. Now J times IA XS for cylindrical rotor machine. So that will be obviously J times IA, that is rotated by 90 degree in anti-clockwise. So this will be, let us say, J times IA XS is this. So this will be our per phase induced EMF E. Fine. This is O point, and this will be our load angle delta. Now consider the third case, that is leading power factor case. So in leading power factor, current phasor IA leads the V by n angle. So right here leading power factor case. So in leading power factor case, procedure will be same. So let us take the case when delta is known. First we will draw for salient pole, then for non-salient pole, that is cylindrical rotor. So when delta is known, so our procedure will be first draw V phasor, V, this is O point, and for this case, leading power factor case, current phasor is leading by certain angle, power factor angle theta, let us say theta. So this is IA, mark it as IA phasor. Once delta is known, so we may draw Q axis. Something like this, Q axis right here, Q axis at an angle delta. Just I am writing here delta. So once Q axis is known, perpendicular to this, D axis is also known. Fine. Now we have to add this drop IDRA. So first write the components of IA along D. This is ID, projection of IA along D axis ID, and this will be IQ, projection of IA along q axis, iq. Now ID RA drop will be along ID. So from V we will draw ID RA that is, our aim is to draw IA RA drop along IA. So let us take this as somewhere, we will see where it is going, somewhere in parallel with IA, let us assume. So this is IA RA drop. So what about IQ? IQ will be along IQ. So this drop will be, okay, just mark, this will be parallel to this, so that the resultant will be IA RA drop. Once we will select suitable scale, then all these conditions will be satisfied easily. So we are drawing roughly. So this will be IQ RA drawn, that is, we have drawn V plus ID RA plus IQ RA plus J times IDXD. This is J times IDXD. So perpendicular to ID. So this is ID. So perpendicular to ID means along Q axis. So this is J IDXD. So draw it, J IDXD. And the last term is JIQ-XQ. This is IQ-XQ. So obviously 90 rotated in anti-clockwise direction, that is this way. So this will be parallel to D axis, J IQ-XQ. Fine. So this will be our per phase induced EMF E phasor, this E. This will be per phase OE, induced EMF. Now let us draw phasor diagram of a salient pole synchronous generator for leading power factor case when power angle delta is unknown. So the same procedure as discussed earlier. First draw the voltage phasor V, and for this case current phasor IA will lead by certain power factor angle theta. This is IA phasor. Now next we will draw IA RA drop, obviously in phase with IA. So let us mark somewhere IA RA drop. Okay, IA RA drop. So from here we will extend IAXD perpendicular to this. So let us extend it perpendicular to this somewhere like this, perpendicular to this rotated in anti-clockwise direction. So this will be IAXD, this length, IAXD length. Now cut IAXQ from here. So let us take any point. Let us say this is IAXQ, this is Q. From here till somewhere here, suppose here or somewhere here. This is the point where we have cut IAXQ from this. We have taken IXD, and from here we have cut a length equivalent to IAXQ from here. Now, if this is our O point, so we will join this dotted line to O. So, what is our next step? Now, from this point, let us say this is A point, draw a perpendicular, same procedure on this. So, let us take this perpendicular as this, and this is our B point where we have drawn the perpendicular. So, this gives our resultant phasor E. This is OE is our resultant phasor E, which is nothing but per phase induced EMF in armature winding of a salient pole synchronous generator, OE. Same procedure, draw V, then draw IARA parallel with IA, then perpendicular to IA, draw IAXD and cut IAXQ from this. Wherever it has cut, join this point with O. So, E will lie somewhere in this point, extended point, either inside. This is leading power factor case, that is why you are getting E even lesser than V, but this is not the case when always E will be lesser than E. It will depend on the dimensions of these two, right, this and this dimension, right. But in case of lagging, you might have observed that E is always greater than V in case of lagging power factor. We will discuss later while solving problems.